Jeff Pierce with the Yoda Guy here. Today I want to talk to you about a little thing that not many people know about, or probably do, or may not know the reasoning behind, but I want to talk today about piston rings. To understand what piston rings are, or what they're used for, you kind of need to understand where they go and their place inside the engine. And they go around the piston itself. So, a piston inside of the combustion engine, designed to go inside the cylinder bore here, to be as close as possible to the cylinder walls. The diameter of this piston, you want to try to get it just big enough to fit inside there to reduce any amount of expanding gases from the combustion process, getting past the side skirts of the piston and going basically into the crankcase, because loss of pressure through that process equals basically loss of efficiency. It's wasted energy, wasted heat, wasted expanding gases, wasted power, wasted horsepower, all those things. So, a piston, usually made out of aluminum. This is an aluminum block, but it has steel sleeve inserts. Now, the thing about that is the aluminum and steel, they do not expand at the same rate. Basically, when you have temperature changes, because combustion temperatures can range into the hundreds of degrees Fahrenheit, the aluminum will expand at a different rate than the steel inside there. So, the aluminum piston has to be as big as it possibly can, but you got to make sure that it's the right size so you don't have basically interference issues with the cylinder walls while it's operating, due to differences in expanding metals. So it's made slightly smaller than the cylinder bore, and then when it gets up to temperature, it'll expand to be almost as tight as possible, but it's still not a perfectly tight seal inside there. You're still going to have a loss of combustion gases going past it. So, back in the day, engineers came up with a little thing called piston rings. And piston rings are basically just a tiny little ring that sits inside these little recesses inside the piston. These rings are specifically designed to, number one, stop combustion gases from getting past the piston, and number two, to help with oil. Oil spreading, there's an oil ring on there as well. So one thing about these is that you got to measure, so they're basically meant to be as tight as possible as well. Now they have an end gap, so they're one piece, but there's a broken end on the end of it. Usually when you're putting in new piston rings, you want to put the piston ring inside the cylinder bore, like so. And you would take a piston and push it into there, make sure it's perfectly flat, but we don't need to do that, you get the idea. Now, it sits inside there, and there's a tiny little gap of where those two end pieces meet. Those can't touch, because with expanding temperatures, or with temperatures going up, that ring is going to expand. Now, if those two little ends were touching, just barely, and that's at ambient temperature, now you throw 300 degrees at that little ring, and on a micrometer level, like tiny level, that ring is going to enlarge in and get a little bit bigger. Now, if that thing is already touching and it tries to expand, it's, instead of closing up that gap, it has nowhere to go, so it expands outwards. And it goes outwards right up against the cylinder wall. And if that happens, you are basically going to score or shear your cylinder walls. You're going to ruin the cylinder walls, you're going to take away your cross-hatching, and you're going to probably ruin the piston as well, get a piston seized in the engine block. So, it's very important to measure your piston ring end gap. So in a repair manual, that gap is located in a repair manual for that spec. And another thing about piston ring end gaps is that they do allow for a little bit of combustion gases to get past them. So it's going to be sealing up pretty well on that edge where it goes up against the cylinder wall. Now with that end gap, you're basically going to have two piston rings on this one. They're compression rings. So when you're installing these things, the trick is to index the piston rings. So the trick is that I'm going to have a gap here in the top of the piston when this thing goes in, and then the other piston ring, I'm going to allow the gap to be on the bottom, see, on the lower side. Now the reason for that is that these are always going to have a tiny amount of gap in them. So we're going to know that a little bit of combustion gases are going to just barely slide through that little gap. Now inside of a cylinder wall, a circular cylinder wall, and then you're talking about inside the reliefs, so if we have one gap right here on the piston, combustion gases get past that first gap. Then it goes down and then it hits basically another piston ring, but the second compression ring that we have in there, the end gap is all the way on the other side of the piston. So if combustion gases are trying to find a way to flow past the piston rings, they have to go down into that little recess, expand all the way around to the other side of the piston, and then go through that end gap. And then a little bit can get past there. And then below the second compression ring is basically an oil ring assembly. So there's this little, it's like almost looks like corrugated cardboard or something, but it's basically an expander ring, and it's meant to be springy. And then you have two tiny little thin rings that go below those. So what those are for is that inside of a piston, there's basically either piston oil holes, or this one has just basically a relief cut inside the piston on that third bottom one down there. Now what that for is for lubrication. Now, cylinder, as the combustion process is occurring, you know, there's really no engine oil being sent up through here. It's just hot expanding gases, fuel, air, combustion occurs, then you get all that fire, flame front and everything that goes through there, then the exhaust opens up and it shoots it all out inside the cylinder bore. Now, all that stuff is inside the cylinder bore, and after a while, that is going to start to basically generate heat, and you're going to start to wear out your pistons and your engine block just from that friction occurring, because there's no lubrication, if there wasn't any lubrication processes. Some engines will have an oil passageway that will get oil to the top of the piston through the connecting rod. Now here's the crankshaft. There are basically little holes cut into the crankshaft, and those little holes get fed by the oil pump. As the crankshaft rotates, each one little of these holes will go past on the main connecting journals. So you have the connecting rod journals, and then you have the main connecting journals. The main connecting journals is where the oil supply gets to the crankshaft. So as this thing rotates, there's oil pressure inside the engine block with holes that are drilled through the entire length of the block, and then where the bearings go, those little guys, I'm going to show you. Oh. That's okay. Okay, so basically, inside this engine block there's little holes, so this is where the crankshaft is going to sit. There's a hole there, hole there, hole there, hole there, hole there. And also in the engine bearings, there's holes as well. So as that crankshaft is rotating around, one of these oil passageways will get shown to this oil passageway in the crankshaft. Now there's oil passageways as well in the connecting rod journals, and those passageways, they're actually drilled straight through the crankshaft, going right into where that main connecting rod journal oil passageway is located. So then you can get pressurized oil sent to the connecting rods. Now the connecting rods, inside the bearings that are on these, they basically have the relief cuts there, so that is sending engine oil to this location. Now there's either going to be a hole, an oil passageway in the connecting rod that will shoot oil straight up to the top, up to the wrist pin, and that'll soak up engine oil there, and it can drip down and stuff like that. And then that engine oil that gets up to the top, where these relief cuts are inside the bottom of the piston ring, that goes straight to the oil ring. And that is meant to put basically fresh engine oil on the bottom side of this ring. And that is meant to lubricate the cylinder walls and the pistons during the combustion process. Now this engine does not have a relief cut, so it's a 1UZ FE V8, Toyota 1992 out of a Lexus LS400. This one does not have an oil passageway going through there. So this one has a little trick thing that they like to use. And inside the connecting rod cap, the end cap, there is a little weep hole. There's basically a hole drilled right through this little passageway there. So as that shoots past and this crankshaft's rotating, that oil passageway in the crankshaft will go across this guy. Now that will allow pressurized oil to shoot out of this connecting rod. So as this thing is going up and down and going through the combustion process, every once in a while this little guy right here shoots out engine oil. And with RPM and everything like that, what happens is that engine oil is going to get flung into the crankcase. And that engine oil gets flung straight up just because of the lateral rotations that are happening. It's eventually just going to spray a little bit of engine oil right up here towards the top of the piston, or the bottom side of the piston itself. It's going to hit up there, and then it's going to seep out through these side parts of where the oil ring is. So that's how this engine basically can cool down the piston from combustion temperatures, because it gets really hot right here, so we try to cool it down on the bottom side of it here. And then another thing that it does is that it laces the side of the cylinder walls with engine oil. So I'm going to show you real quick here. I'm going to basically install these. So we got to remember to index our cylinders properly. Now I'm going to be installing my oil ring right now. So there's basically the expander ring for the oil ring. It's the one that's all weird looking and stuff. That one, basically, it actually does touch inside the cylinder wall, but because it is like a square shaped all the way through, almost like a sine wave, an analog or digital sine wave, what it's going to happen is that it's going to be able to compress. Now this ring physically will never touch the cylinder walls, because there is a little relief at the bottom of this ring, where when you have the oil rings that go around the expander ring, it sits on that little shelf inside the ring holding the oil ring out. It's basically meant to automatically expand itself. So we'll put that guy down. You're supposed to put the end gap right at the wrist pin. So we put the end gap right on the wrist pin. Now we're going to take our first oil ring, the bottom one, and we're going to index it away from that end gap, because we're going to try to maintain as much compression as possible. So we're going to offset all of our end gaps all the way through. So the way that you put on oil rings is that you want to offset the oil ring end gap 1 inch off the side of the expander ring. So we'll go ahead and install this guy here, being very careful because piston rings are very fragile. I don't often use tools here because sometimes you might get a little too aggressive and expand one out too much. But maybe you can, maybe you're good with it. I just like to do it by hand, use my fingers here. Okay, so I got that one there, and I got it basically indexed about, 15 degrees off center from where the end gap is from the expander ring. So then we'll take on our second one. So instead of having our end gap be on the same plane as that one, we're going to put it 15 degrees in the opposite direction, because we want to allow for a little bit of basically expansion to occur, and we don't want our oil rings to get caught on that end gap of that expander ring. Okay, so those are in there. They're a little bit bigger diameter than the piston is, and then when this thing gets compressed, those oil rings go right into the expander ring and push right on it and kind of make that expander ring shrink down a little bit. And that is what allows the oil rings to have tension to push out. Now, crazy thing about the other oil rings. There is basically tension that is being pushed out against the cylinder walls because these are a little bit expanded out. Now, there is a way, a very clever way, of how piston rings seal up the cylinder walls even further. And it uses the combustion process to its advantage to try to allow that to occur. So, on the piston ring, they are directional. This one has a top, and then on the top side, on the inner portion of the ring, there's a chamfer. Chamfer basically means an angle to the flat part. So normally it's like a square like this. A chamfer is like making an angle like that. This plane right here is called a chamfer. So that's on the inside of where the piston ring goes. So that's facing towards the inside of the piston ring. Now, one thing that happens during the combustion process, you get basically a large amount of pressure that happens when the combustion occurs, and you get a combustion, the flame flow that happens. Pressure inside the combustion chamber skyrockets. It goes up really high. That combustion gas is wanting to go right past these cylinder walls as it's trying to push the piston down. Now, with that chamfer inside there, combustion gases will come in and they're going to be pushing down on the piston ring. So there's going to be a tiny little gap where the piston ring can be pushed down to almost seal itself on the bottom side of the piston ring, right inside the channel where it sits. And what happens is what that chamfer allows for, it allows for expanding gases to get behind the oil ring, basically on the inside of the oil ring. And then what that does is it shoots out pressure against the oil ring, so it pushes up against the cylinder walls tighter than it did before. And then your second piston ring does the same thing. It has that same little expanding chamfer. So it's using combustion gases to help seal the cylinder wall inside there. So I'm going to put on this other one, and then we're going to talk about something about oil and stuff. So this one, so I have my expanding end gap or expanding ring there, and then I have my two end gaps for the oil ring. So I'm going to take this compression ring number 2, and I'm going to put it on the opposite side of the cylinder. On the opposite side of the piston. So to try and enhance as much compression within the engine as possible. Okay, we got that guy in there, and then we check to make sure he moves around freely. Perfect. We take our top cylinder, or top piston ring, compression ring number 1, and make sure it's going in the right direction. Double check your work. Always double check your work. So we're going in, and remember we're putting this end gap on the opposite side of the piston. One end gap's right there, another end gap's right here, oil ring end gap's here, and then that just makes it so the combustion gases have to go all the way around the piston several times just to get down past the skirt. Now, one thing about piston rings is that not many people realize is that oil is a big thing for these things to be lubricated and stuff like that. If you ever heard the term of a sludger engine, where you get oil sludge built up in the valve train, basically thick masses of carbon build up all over the engine, it's just really thick engine oil. That not only affects the mechanical parts of your engine block, with your camshafts, crankshafts, connecting rods, just basically your whole lubrication system, it also affects your piston rings. And what happens is that when you get that oil sludge built up, it'll build up inside the oil ring. And then that can cause lack of lubrication to the other piston rings because they need a little bit of oil. Because as that thing's going up and down the cylinder wall, the piston ring will kind of allow oil to be soaked on the piston wall, it goes down, and then as the piston ring goes back up, it's kind of sucking a little bit of that engine oil up. And that's where typically you have a little bit of engine oil loss. Engine oils naturally lose oil. And